morning everyone. My name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. This lecture we are going to see multiplication bias and division bias of inverse Laplace transform. Using inverse Laplace transform, let us see the problems on multiplication by powers of s and division by s. Let us see the statement of multiplication by powers of s. If L inverse of f bar of s, so if L inverse of f bar of s is f of t, this is by definition of inverse Laplace transform, and the condition is f of 0 equal to 0, then the statement is L inverse of s into f bar of s is f dash of t. When we multiply the function f bar of s with s, we have to differentiate it once. If we want to find L inverse of s square into f of s, so first we find f of t, that is L inverse of f bar of s, then we differentiate it twice, d square by ds square of f of t. So in general, if we multiply f bar of s with s power n and we want to find inverse Laplace transform, the formula is f power n of t. This denotes nth derivative of f at t, provided f power n of 0 equal to 0. What does it mean? F power n of 0 means nth derivative of f at 0. It should be equal to 0 for n equal to 1, 2 and so on up to n minus 1. So let us see the problems on it. First one, find L inverse of s upon s plus 2 whole square. Right. We can write this as L inverse of s into 1 by s plus 2 whole square, isn't it? Now this is in the form of L inverse of s into some function of s, that is f bar of s. So let us take this function as f bar of s. So here f bar of s is 1 upon s plus 2 whole square. For this function, let us find inverse Laplace. What is L inverse of f bar of s? That is L inverse of, what is f bar of s here? 1 upon s plus 2 whole square. Since s plus 2 whole square is there, let us apply first shifting theorem. This can be written as e power minus 2t into L inverse of 1 upon s square, isn't it? So what is L inverse of 1 by s square? This can be written as, therefore L inverse of 1 by s plus 2 whole square e power minus 2t into t. L inverse of 1 by s square is t. This is some function of t, let us denote it with f of t. Now we want L inverse of s by s plus 2 whole square. As per the definition, I can write this as minus 1 into d by dt of f of t. So minus d by dt of, what is f of t here? E power minus 2t into t. So there are two functions, one is e power 2 minus 2t and another one t. Let us apply UV rule derivative. So this can be written as e power minus 2t into t derivative 1 plus t into, what is the derivative of e power minus 2t? Minus 2 e power minus 2t, right? So if I take e power minus 2t common, then minus 1 minus 2t, or if I take, so this is the L inverse of s by s plus 2 whole square. Let us see one more problem. Find L inverse of s minus 3 by s square plus 4s plus 13, right. So, this can be written as L inverse of s upon s square plus 4s plus 13 minus 3 times of L inverse of 1 upon s square plus 4s plus 13, right. So, first let us see how to find this inverse Laplace of 1 by s square plus 4s plus 13. How to write this? S square plus 4s is there here. This comes under which expansion? I can write this as s plus 2 whole square. What is s plus 2 whole square? S square plus 4s plus 4, but here we have plus 13. So, additionally we add 9. L inverse of 1 upon s plus 2 whole square plus 9 can be written as 3 square, right. Now, using first shifting theorem, how can we write this? E power minus 2t into L inverse of 1 upon s square plus 3 square. How we have written this? Using first shifting theorem. Right. Now, we have one formula, L inverse of 1 upon s square plus a square. You know that the formula is 1 by a sin a t. So, here we have 3, a is equal to 3. So, this can be written as e power minus 2t 1 by 3 sin 3t. Let it be equation 1. This is some function of t, let us assume some f of t, right. Now, this is equation 1, equation 2. So, substitute equation 2 in equation 1. So, from equation 1 what can we write? L inverse of s by s square plus 4s plus 13 minus 3 times of L inverse of 1 by s square plus 4s plus 13 can be written as e power minus 2t by 3 sin 3t. So, 3 get cancelled. Now, we have to find this value using multiplication by s. So, this can be written as L inverse of s into 1 upon s square plus 4s plus 13 minus e power minus 2t into sin 3t, right. Now, when you assume this function as f bar of s, we are multiplying with s. So, what we have to do? We differentiate f of t. Here this is f of t. So, this can be written as 1 by e power minus 2t by 3 sin 3t. We differentiate this one time since we are multiplying with s. So, this can be written as f dash of t minus, what is the previous thing we have got? F of t e power minus 2t by 3 sin 3t, e power minus 2t by 3 sin 3t. So, 1 by 3, how will you write f dash of t? E power minus 2t into, what is the derivative of sin 3t? 3 cos 3t plus sin 3t into derivative of e power minus 2t is minus 2 e power minus 2t minus this as it is e power minus 2t by 3 sin 3t. So, further if you simplify, e power minus 2t by 3 into 3 cos 3t plus minus plus into minus minus 2 by 3 e power minus 2t sin 3t minus e power minus 2t by 3 sin 3t, right. So, e power minus 2t by 3 here, sorry, 3 get cancelled into cos 3t minus 2 by 3 1 by 3 3 by 3 is 1. So, minus e power minus 2t sin 3t. So, this is how we find the inverse Laplace using multiplication of s. So, how we have done this? First find inverse Laplace of f bar of s. That function, whatever function you get, f of t. So, to find inverse Laplace of s into f bar of s is f dash of t. So, whatever function you get here, you just differentiate it. If you multiply with s square, you differentiate it twice, right. Let us see one more problem. Find L inverse of s by s square minus a square. This I can write it as L inverse of s into 1 by s square minus a square. So, s into f bar of s. What is f bar of s here? 1 upon s square minus a square. Now, you know what is L inverse of f bar of s. Direct formula is there. L inverse of 1 by s square minus a square. This can be written as 1 by a sin h a t. Now, we want L inverse of s into 1 upon s square minus a square. So, this function you let us assume as some function of t, which is denoted by f of t. This is minus 1 into d by dt of f of t, that is d by dt of, what is f of t? 1 by a sin h a t, minus 1 by a, let us write it outside. Derivative of sin h a t is a into cos h a t. So, here a and get cancelled, this is minus cos h a t, right. So, this is how we find the L inverse of function which is powers of s. So, let us see division by s. L inverse of f bar of s is f of t. This is by definition of L inverse Laplace. Then how to find inverse Laplace of f of s by s is integral 0 to t f of u du. First we find L inverse of f bar of s, that we denote with f of t. Once you know f of t, we can write what is f of u, isn't it? So, that you replace here f of u du, you integrate between the limits 0 to t. Suppose if you divide f bar of s with s square, then we integrate twice. Suppose if you want to find L inverse of f of s by s cube, since we are dividing with s 3 times, that is s cube, we integrate 3 times f of u du between the limits 0 to t, right. So, let us see one problem on it. Find L inverse of 1 by s into s square plus 2s plus 2, right. We have to write this in the form of division by s. So, let us write this as L inverse of 1 upon s square plus 2s plus 2 total divided by s. I am just writing this to represent that this is in the form of L inverse of f bar of s by s. So, you compare these two here, what will be the function f bar of s? F bar of s is 1 upon s square plus 2s plus 2. This function can be written as 1 upon s plus 1 whole square plus 1, isn't it? Now we find inverse Laplace of f bar of s. L inverse of 1 by s square plus 2s plus 2 can be written as, how to find L inverse of this? 1 by s plus 1 whole square plus 1. Since we have s plus 1 terms, we apply first shifting theorem. Using first shifting theorem, how can we write this? E power minus t into L inverse of 1 upon s square plus 1. Using first shifting theorem, right? Now, what is L inverse of 1 by s square plus 1? 1 by a sin a t. Here a means 1. So, this can be written as e power minus t sin t. This I am assuming as some function of t, let it be f of t. So, to find L inverse of f bar of s, we integrate the function f of t. Therefore, L inverse of f bar of s by s, this can be written as integral 0 to t f of u du. This is f of t e power minus t sin t. I want f of u. So, in place of t, replace with u. So, e power minus u sin u du. Now, you know how to integrate this. There is separate formula. We do not apply integration by parts for this. So, this can be written as, what is integration of e power ax into sin bx dx? The formula is e power ax upon a square plus b square into a sin bx minus b cos bx. This is the formula to evaluate this integral. You compare these, and what is a and what is b here? E power ax, here e power minus u. So, we replace a equal to minus 1 and b is equal to 1. So, this integral can be written as e power minus u by a square plus b square into a sin bx minus sin u minus b cos bu, b means 1, into cos u, and we substitute the limits 0 to t. So, this can be written as, once again we write integral 0 to t e power minus u sin u du. This can be written as e power minus u upon a square plus b square into a sin bu. A means what? Minus 1 minus sin u minus b cos bu. B means 1 into cos u. For this, we apply the limits 0 to t. So, upper limit u equal to t. So, e power minus t by 2 minus sin t minus cos t. This is upper limit. Minus lower limit, in place of u, if substitute 0, e power 0 is 1. So, 1 upon 2. What is sin 0? 0. Cos 0 is 1. So, e power minus t by 2 into minus sin t minus cos t, minus of minus plus, so 1 by 2. So, this is how we find the division by s. Let us see one more problem on this. Find inverse Laplace of 1 by s into s square minus 1 into s square plus 1. Since we had, let us apply division by s. So, let us take f bar of s as 1 upon s square minus 1 into s square plus 1. For this we have to apply inverse Laplace. Directly we cannot apply. First let us using partial fractions. So using partial fractions, this can be written as 1 by s square minus 1 minus 1 by s square plus 1. If we write like this, let us check whether both are equal or not. So what you will get if you take out the LCM, s square plus 1 minus s square plus 1 by s square minus 1 into s square plus 1. So s square cancel, you are getting 2 by s square minus 1 into s square plus 1. So let us divide with 2. Now these two are equal. How we have written this? Using partial fractions. Using partial fractions we can write. Now apply L inverse to the function f bar of s, that is L inverse of 1 by 2 into 1 by s square minus 1 minus 1 by 2 into 1 by s square plus 1. What is L inverse of 1 by s square minus a square? Sin h a t. Here a means 1. This is sin t. Now this function I am assuming as f of t. Now L inverse of f of s by s. Since you are dividing by s, we integrate the function f of t. This is the function f of t, 0 to t, f of u du, sin h u du minus sin u du. So we integrate this. So this can be written as sin h u integration is minus h into cos h u minus, already sin integration minus, so minus of minus plus, sin u integration is cos u, between the limits 0 to t. So if you substitute the limits 0 and t, this 1 by 2 into h into cos h t plus cos t. This is upper limit. Lower limit, substitute u equal to 0, cos 0 is 1, so minus h plus 1. So cos 0 is 1. This is how we solve inverse Laplace using division by s, right? So totally we have discussed multiplication by s and division by s in this lecture. Next lecture we will be seeing on convolution theorem and problems on it. Thank you.